All right, so for example number 4, this is where it gets tricky. They want us to integrate a somewhat complicated, and these are usually going to be rigged up, all right? So keep that in mind. They want us to find the antiderivative or the indefinite integral of sine of x times e to the cosine of x. No problem. We'll just crank through and find the antiderivative of that. Can we do that?
Yeah, can we?
Well, it looks complicated the way that it is. But these are rigged up in a way, and this is the interesting thing. What would make this easy to do?
Not having the cosine raised to the e.
Yeah. So if I let u equal cosine of x, then u prime would be sine of x, right? And this is what I mean by they're rigged. In other words, if I take the antiderivative of this, but I use u substitution, I literally have e to the u prime. Another way to think of that, if we use the Leibniz notation, is e to the u du. What's the derivative of e to the u? E to the u, right? E to the x, e to the u, e to the any variable, e to the smiley face, when you take the derivative of it, is just e to the whatever the variable is. So the antiderivative of e to the u du is just e to the u. What is e to the u? E to the u is e to the cosine of x. That's the antiderivative. Oh, plus c, right? Because it's a family of derivatives, family of functions. Now the only other thing that I forgot to do is technically the derivative of cosine of x is negative sine, right? So technically I have to put that negative in there somewhere because they gave me this sign. So it's technically got a negative and I'm just going to toss it to the front, right? So technically I've got negative e to the u, and so technically we've got negative e to the cosine of x. I apologize, I forgot all about the negative sign. I got so excited that it worked out. Okay? Are any questions there?
Yeah, I just don't really get it. Why did we do the u prime? And like, why did we have u prime equal the negative sign?
Oh, okay, so
I'm just like, I'm confused on like what you did and why you put stuff where.
okay, well let's do the next example. We'll just crank through a bunch of them and see, okay?
Okay.
So if I do example number 5, and then just pay attention, and maybe it'll become a little more clear. That was the first time you've seen that done, okay? So for example number 5, what they want us to do is they want us to find the integral of x squared times the square root of 5 plus 2x cubed dx. Now here we've got like a product rule and stuff like that, so this is a little more challenging. But what I could do, if I let u equal something, this is, so think conceptually, I'm going to choose u to represent some expression of x. It could be x squared, it could be 5 plus 2x cubed, I'm not quite sure. But I'm going to choose a u value, and what I'm going to do in the next step is I'm going to find, it should work out, instead of f of x dx, I'm going to have something like f of u du, and this will be very easy to find the antiderivative. So the whole process of u substitution is to pick an expression of x, set it equal to u, take the derivative of it, and it should eliminate the other x thing. So, watch carefully. I'm going to let u equal this stuff. When I let u equal that stuff, this right here will probably in some way, shape, or form become du. Then I will have a function of u and du. And then I could just integrate. And it'll be a lot easier to integrate than the current f of x. Because right now, what I have up here, right now, this stuff right here is the integral of f of x, the indefinite integral, dx, but it's really complicated. So the goal is to pick something of u. I'm going to say u equals 5 plus 2x cubed. So then du would equal 6x squared. See how that worked out?
Wouldn't it be plus 5x?
No, we're taking the derivative. Right? We're taking the derivative.
Oh, okay. Okay.
Right?
Yeah.
So now it's not, like I said, these problems are rigged up. What do you see here?
X squared.
X squared. So now here's, I don't know, I've taught this two ways. The way that I learned this is, what am I trying to substitute? 6x squared or x squared? Well, I'm trying to substitute this x squared, but what do I have?
6.
So if I take this and divide by 6, and this is why Leibniz notation is a little easier to use, these cancel and I get x squared is equal to du over 6, or 1/6 times du is equal to x squared.
Okay.
Okay.
Then it's
So then my function of u, this stuff right here, my function of u becomes 1/6 du, right? That's going to be my x squared times the square root of u.
okay.
Does that make sense? Now, in the next step, what I'm going to do is I'm going to rewrite this. I could take any constant and toss it to the front. So I'm going to say 1/6 times the antiderivative of the square root of u du. Or 1/6 u to the 1/2, whoops, not negative 1/2, just 1/2, du. Is that right so far?
Mm-hmm.
So now, this is where the antiderivative for 1/2, or u to the 1/2, isn't that hard. We're going to add, so the 1/6 remains out here. When you add 1 to this, you say 2 over 2, so I'm going to get u, and then I have to the 3/2, right? But I want to divide by this number. I don't know if you've recognized that pattern or not, but whenever we take an antiderivative, we add 1 to the power, and then we divide by whatever that new power is. But we would be dividing by 3 over 2. And we'll come back to that in a second, right? And we don't need to write the du. This is pretty much it, okay? Plus c. But when you divide by a fraction, what do you really do?
Multiply the reciprocal.
Multiply by the reciprocal. So what this really becomes is 1/6 times 2/3 u to the 3/2 plus c.
So that's the antiderivative.
Yeah, and then that's the antiderivative. Now you can clean that up a little bit if you want to.
No, okay.
So you could like 1/6, like you can multiply these two together. This reduces down to 1 over 9. It's really 2 over 18. And then we have u to the 3/2 plus c. But remember, we want this written in x. So remember that u is 5 plus x cubed. So your final answer then would be 1/9 times 5 plus 2x to the third raised to the 3/2 plus c. So that's your final answer. And you know, keep in mind this is the second time you've seen this, so you're not going to be 100% with it. Right? You just got to practice it. But with u substitution, the problems are almost always going to be rigged to where you're going to have a function of x, so you're going to integrate f of x dx, but you're going to arbitrarily choose some value for u that will kind of work out to be f of u du. And then you integrate, and the f of u du integration is a lot easier than the x integration.
That
in theory.
probably made sense. It didn't explain the one above, but I get what we're doing.
Oh yeah, it does. So we did the exact same thing. So on this one, if we were to redo this, maybe I just want to, let me redo it again. Here we have a function of x, dx, right? I didn't write the dx, but it's there. And we want to integrate that. Well, that's hard. So our goal then is to arbitrarily choose some u value, so I get f of u du. That's easy. So this is hard to do. And I want to be able to do this and make it a little easier. So if I let u equal cosine of x, then du is actually equal to negative sine of x. Now, if I toss that with this negative thing, see, I have sine of x here, and I have sine of x here. So I got to address this negative sign. So if I multiply both sides by a negative, I get negative du is equal to sine of x. So now I'm going to come in and I'm going to substitute this because I've got my negative du times e to the u. And technically, if I wanted to be real formal, I've got this dx here, right? If I use the Leibniz notation, du dx, if I multiply this on both sides, I get this. So that even takes care of this. I just been kind of skipping it. I probably shouldn't, but I have. So now if that's the case, I could take this negative sign and toss it to the front, so I get negative e to the u du. And that's real easy to integrate because the negative sign goes to the front, the derivative of e to the u is e to the u, and vice versa, the antiderivative is e to the u. Then we tack on plus c. But remember that u was cosine of x, so we plug that back in. That's the antiderivative. Does it make a little more sense as I explain it the second time?